Use the intermediate value theorem to show that there is a root of the given equation in a specified interval. Now let's say the function f of x is equal to x squared minus x minus 12, and the interval is 3 to 5. So how can we answer this question? How can we show that there's a root of the given equation? So let's talk about the intermediate value theorem and how it applies to this problem. Let's say if we have a continuous function from point A to B. So f of A, let's say it's equal to a value -5. And f of B, let's say it's equal to 10. So there's some value C where f of C is 0. And it makes sense. In order for you to go from -5 to 10 on a continuous function, you have to pass through 0 at some point. And that's the main idea behind the intermediate value theorem. There's some number that is in between -5 and 10, which is 0, and the x value that corresponds to that y value of 0, we're going to call it C, and C has to be somewhere between A and B. So for there to be a root, f of 3 and f of 5, one of them has to be positive and the other has to be negative. If that is true, then somewhere between 3 and 5, there's some number f of C that is equal to 0. So first, let's make sure that f of 3 and f of 5, one of them is positive and the other is negative. So let's calculate f of 3. If we plug in 3 into the equation, it's 3 squared, which is 9, minus 3, which is 6. 6 minus 12 is -6. So we have a negative number. So then the other one has to be positive. Otherwise, we can't use the intermediate value theorem. Now let's find f of 5. So that's going to be 5 squared minus 5 minus 12. 5 squared, which is 5 times 5, that's 25. 25 minus 5 is 20. And 20 minus 12 is positive 8. So we could see that one of them is positive and the other is negative. Therefore, somewhere between f of 3 and f of 5, the y value has to cross 0. So there's some number, f of C, where C is between 3 and 5, such that f of C is between -6 and 8. So there's some number f of C that's 0. Since 0 is between -6 and 8, C has to be between 3 and 5. Let's go ahead and find that value of C, which is a root of the given equation. If it's a root, basically you're finding the zeros. So what we're going to do at this point, we're going to set the function equal to 0. And we're going to find the root, which is basically the C value. Notice that we have a trinomial with a leading coefficient of 1. Whenever you have that, you can factor it. Find two numbers that multiply to -12, but that add to -1. What are those two numbers? It turns out that -4 times +3 gives you -12, but -4 plus -3 adds up to -1. So to factor it, it's going to be x minus 4 times x plus 3. So we have two possible answers. X is equal to 4 and x is equal to -3. Now here's a question for you. Which of these two values is equal to C? Is it +4 or is it -3? So which one is in the interval? Which one is between 3 and 5? The answer is 4. -3 is not between +3 and 5. So therefore, the answer for this problem is C is equal to 4. As we could see, f of C, or f of 4, is equal to 0. So since 0 is between the y values of -6 and 8, the x value 4 is between the x values 3 and 5. And that's the main idea behind the intermediate value theorem. Now let's try another example. So let's say we want to use the intermediate value theorem to find the value of c in the interval. And this time, c is not going to be a root. It's not going to be on the x-axis. So let's say if f of x is equal to 2x squared plus 3x plus 5. And you want to find the value of c in the interval, let's say 1 to 4. And let's say that you're given the value of f of c. Let's say f of c is not a root, but f of c has a value. And you're told that f of c is 19. What would you do to find the value of c? Now the first thing you need to do is you need to plug in the endpoints of the function. Pretty much the same as what we did last time. So let's find the values of f of 1 and f of 4. Now we know the function is continuous. Anytime you have a polynomial function, it's always going to be continuous. F of 1, if we plug in 1 into the equation, what do we get? So what's 2 times 1 squared plus 3 times 1 plus 5? So this is 2 plus 3 plus 5, which gives us a value of 10. Now what about f of 4? What is the value of f of 4? So this is 2 times 4 squared plus 3 times 4 plus 5. 4 squared is 4 times 4, which is 16, times 2, that's 32. 3 times 4 is 12. If you add 32 plus 12, that's 44 plus 5, so you get 49. So with this information, how can you tell if we can use the intermediate value theorem? Notice that 19, which is a y value, it's between the two y values of 10 and 49. So since 19 is between 10 and 49, c, which is an x value, is between the x values of 1 and 4. So on a graph, let's say if we have a curve that looks something like this. And let's say f of 1 has a value of 10 and f of 4 has a value of 49. Then this, at some point, there's some value of c where the function has a value of 19. So at some point f of c is 19 if we have a continuous curve. And it makes sense though. For you to go from 10 to 49, at some point you have to cross 19. So as you travel from 1 to 4, you have to reach some c value where it's equal to 19. So that's how we can apply the intermediate value theorem, or at least that's how we can make sense of it in this particular problem. So what we need to do is replace f of x with 19 and solve for x, which is going to be the c value. So 19 is equal to 2x squared plus 3x plus 5. So what would you do to solve for x in this particular problem? What's the first step that you would take? The first thing you should do is subtract both sides by 19. So 5 minus 19 is negative 14. And then you want to factor the expression. So this time we have a trinomial where the leading coefficient is not 1. So to factor it, multiply the leading coefficient by the constant term. So 2 times negative 14 is negative 28. And then ask yourself, what two numbers multiply to negative 28 but add to positive 3? The answer is 7 and negative 4. Positive 7 times negative 4 is negative 28, but positive 7 plus negative 4 adds up to 3. So what you want to do at this point, you want to replace positive 3x with negative 4x plus 7x. And notice that the value of the expression remains the same. Negative 4x plus 7x equals 3x. So you haven't changed the value of this expression. So now what you want to do is you want to factor by grouping. Take out the GCF from the first two terms and the last two terms. In the first two terms, we can take out a 2x. 2x squared divided by 2x is simply x. Negative 4x divided by 2x is negative 2. Now from the last two terms, we can take out a 7. 7x divided by 7 is x. Negative 14 divided by 7 is negative 2. Now, if these two terms are the same, that means you're in the right direction. So let's take out x minus 2. If we factor out x minus 2, it's going to be 2x plus 7 inside the next parentheses. Now we need to solve for x. So if we set each factor equal to 0, if x minus 2 is equal to 0, we'll see that x is equal to positive 2. Now if we set the other factor equal to 0, 2x plus 7, we'll have to subtract 7 from both sides, so 2x is equal to negative 7, and then divide by 2. So x is negative 7 over 2. So now one of these x values is going to be the c value. Negative 7 over 2 is like negative 3.5, so that's not between 1 and 4. So this is not the c value that we're looking for. But 2 is in the interval of 1 and 4. So therefore we could say that c is 2. F of 2 is equal to 19. And so that's how you could find the value of c in the interval. So make sure you find f of 1 and f of 4 first, and then make sure that f of c, the y value, is between these two y values. Once those conditions are met, replace f of x with 19, solve for x, and find the value of x that is in the interval. And that value of x is equal to the c value that you're looking for. So that is it for this video. Now you know how to use the intermediate value theorem to find the root or to find the value of c in the interval. So thanks for watching.